Good morning to all. Today our chapter is vectors. Last class I have done. Today also I am continuing the chapter vectors. Okay. Let me give the some question. For what value of A, the vectors 2i minus 3j plus 4k and ai plus 6j minus 8k are collinear. Two vectors given and you have to find out the unknown quantity, that is A, by which the two vectors are collinear to each other. Collinear means they are present in one line. If A and B are collinear, then A vector is equal to lambda into B vector. This is the condition for collinear. Lambda is a scalar quantity that you have to find out. Now put the value of first vector, that is I have written ai plus 6j minus 8k equal to lambda into second vector 2i minus 3j plus 4k. After that, if you open the bracket and multiplying lambda with each element coefficient of I, j, k and comparing both sides, a is equal to 2 lambda, I coefficient, j coefficient 6 is equal to j coefficient minus 3 lambda. Here you will get lambda value, that will be minus 2. Again k coefficient minus 8, here k coefficient will be 4 lambda. So lambda equal to how much? Minus 2. After finding the value of lambda here, then put the value of lambda here in first. That will be 2 into minus 2, it will be a equal to minus 4. Hence the given vector are collinear if a is equal to minus 4. A is equal to minus 4. This is the answer of number 1. A is equal to minus 4. Let us go to the second number. Let me read the question. Second number is given here. Find the value of P for which the vectors 3i plus 2j plus 9k and I minus 2pj plus 3k are parallel to each other. So what is the condition for parallel to each other? That means the given vector, first vector and second vector given are parallel if the first vector is equal to lambda into second vector. Here unknown quantity is p, you have to find out. Same process, comparing both sides, the coefficient of I, coefficient of j, coefficient of k. I means unit vector along x axis, j is the unit vector along y axis, k is the unit vector along z axis. Comparing, lambda is equal to 3 and minus 2p lambda is equal to 2, and here 3k coefficient 3 is equal to 3 lambda is equal to 9. So from here you will get lambda value, that is 3. Same thing you are getting or not. After that, put in the value of lambda here in second equation, you will get the value of unknown quantity, that is p coming minus 1 by 3. Two question completed. Let us go next question. Question number 3. Show that the vector I plus j plus k is equally inclined to the coordinate axis. There are three axes, x axis, y axis and z axis. It is equally inclined to the coordinate axis. Let the given vector r, that is I plus j plus k. The direction ratio of this given vector I plus j plus k, coefficient of I is what? 1. Coefficient of j, that is 1. Coefficient of k, that is 1. So this is called direction ratio of the vector r, that is 1, 1, 1. Next you have to find out magnitude of the vector r. I coefficient whole square plus j coefficient whole square plus k coefficient whole square root over, that will give you root 3. Next you have to find out direction cosine of the vector r. The direction cosine formula is cos alpha. Alpha is the angle made by the vector with the x axis, that is denoted by L. Formula is what? A by a square plus b square plus c square root over. Here a means here 1 and the root over you got, that is root 3, 1 by root 3. Cos gamma, alpha beta is the angle made by the vector with the y axis, that is denoted by m, is equal to b by a square plus b square plus c square root over. A, b, c are the coefficient of I, j, k in the given vector. B is the coefficient of j, that is coming 1 by root 3. Next coming cos gamma. Gamma is the angle made by the vector with z axis, which is denoted by n, equal to c by, c means the coefficient of k vector, that is c by, c coming 1 by root 3. In this way, all the threes are coming equal: cos alpha, cos beta, cos gamma, which is equal to 1 by root 3. Therefore, angles are equal. Alpha is equal to beta is equal to gamma. So, what is the condition you got? Whenever the three cosines are equal, the three angles are equal to each other. Yes or no? Therefore, hence the given vector is equally inclined. The given vector is equally inclined to the coordinate axis. You know. The vector r makes alpha, beta, gamma angles with the coordinate axis. This is the practical figure x-axis, y-axis, 3D figure z-axis. Alpha is the angle made by the vector OP, position vector given 1 1 1 alpha. Beta is the angle made by the vector OP with y-axis. Gamma is the angle made by the given vector with the z-axis. In this way, question number 3 completed. Okay, let us go to number 4. Question number 4. Find a vector of magnitude 11 units in the direction opposite to PQ, where P and Q are the points that is given 132 and minus 108 respectively. So given P given 132 and Q given minus 108. So let O be the origin, your reference point. OP will be how much? IJK form you write I plus 3J plus 2K, and OQ will be minus I plus 0J plus 8K because it is given 0. After finding OP and OQ, then find PQ. PQ will be OQ, position vector of Q minus position vector of P. In this we are getting 2i minus 3J plus 6K. Okay. The vector in the direction opposite to PQ, which is equal to QP, that is nothing but minus PQ, just minus multiply with PQ, it will be 2i plus 3J minus 6K. Next you have to find out the magnitude of QP. I coefficient whole square plus j coefficient whole square plus k coefficient, that is minus 6 whole square root over. It is coming 7. That unit vector in the direction of QP, it will be QP vector by QP vector mod and the magnitude. QP vector you got as 2i plus 3j minus 6k divided by mod you got 7. That means 1 by 7 whole 2i plus 3j minus 6k. A vector of magnitude 11 in the direction opposite to PQ, it will be just you have to multiply 11 with the unit vector. That means 11 by 7 2i plus 3j minus 6k. This is all about the basic concept about the vector chapter. Few questions would have completed. Thank you for today's class. Try to complete more sum in the vacation. Thank you for today's class.